Assalamualaikum and hi everyone. So this is a lecture video for BMCG 1013 Differential Equations. We are still in chapter 3 Laplace Transform. In this week lesson, we will cover the two LOs which are to express a function in the form of unit step function and to find the Laplace transform for unit step function. 3.2 Unit step function. A unit step function ut minus alpha is defined by this equation. So ft is equal to u unit step function, t minus alpha is equal to 0 for t less than a and 1 is for t greater or equal to a. And the graph for this function, this is just an example for the unit step function. This is the graph, okay, for t less than a, it is 0. So 0 from here, from 0 to a. And then for t greater than a to the infinity, we have this line, straight line, where ft is equal to 1. Okay. The notation for unit step function is either ut minus alpha or u alpha t. Okay. Or we can also call this as Heaviside. Okay, with notation h replacing u. So we can have h t minus alpha instead. Writing ft in the form of unit step function, given a piecewise function ft equal to, for first function f1t, it is for t from interval 0 to a. And the second f is f2t, and this is for t greater or equal to a. So for this one, if you want to write ft in terms of unit step function, you have ft f plus 1. So start with writing your f1t, and then the second steps you need to plus with, f2t minus f1t. So this is the second step, and then write your unit step function ut minus a. Okay, and if we have three functions, f1, f2, and f3. Okay, so this is the interval for each function. So to write ft, you have f1t first, plus with f2t minus f1t, and then this is the unit step for second term. Okay, f2 minus f1 ut minus a. And then the last term is you need to plus with f3 minus f2. And this is the unit function ut minus b. Example 3.5, you need to write the following piecewise functions in terms of unit step function, and you need to sketch the graph. Okay, let's try with a first. Okay, we start with ft equal to 0, 1, t less than 2 and greater than 2. So first, write ft in unit step function. Ft is equal to 0 plus with 1 minus 0. So 1, and then u t minus 2. So this is equal to u t minus 2. And the graph for this is, we have ft and t. Okay, for t from 0 to 2, okay, you have ft equal to 0. So you have 0 to 2. And then for t greater than 2, your function is equal to 1. So for t from 2 to infinity, you have 1. So this is the graph for the first example. For the second example, ft is equal to 0 plus t minus 0. So t u t minus a, 5. This is equal to t u t minus 5. And the graph have t and ft from 0 to 5, you have 0. 0 to 5, you have 0. And for greater than 5, t greater than 5, you have t. If t is equal to 5, then you have ft equal to 5. T equal to 6, your ft is 6. T equal to 7, your ft is 7, and so on. So this is the line for t. Y equal to t. Okay, so this is the graph for second function t. And for C last, we have ft equal to 0 plus with 1 minus 0, 1, and then u t minus 3 plus 0 minus 1 minus 1 u t minus 6. So now you have u t minus 3 minus u t minus 6. And for the graph, ft and t. We have 3, t equal to 3 to 6. Okay, from 0 to 3, the graph is at 0. So 0. Then from 3 to 6, the graph is at 1. So you have this 1, this is 1, and last, and 6 to infinity, you have 0. This is how we write the piecewise function in terms of unit step function and sketch the graph. Now we will look at the Laplace transform for unit step function. So we have second shifting property. If alpha is less than 0 and Laplace of ft is equal to fs, then to find Laplace transform of unit step function is equal to, you have exponent negative alpha s, the same alpha as here. Okay, and then we need to find Laplace for this ft, or it is equal to exponent negative alpha s fs. And this is the table for unit step function, Laplace transform for unit step function. If we have ut minus 1, okay, for example, so it is 1 over s exponent negative 1s. If you have ut minus 5, so it is 1 over s exponent negative 5s. Again, and the second one, ft minus alpha, ut minus alpha, it is equal to exponent negative alpha s fs. It is from second shifting. For example, if you have t minus 2, ut minus 2, so you have exponential negative 2s, and fs for this t minus 2 is equal to 1 over s square. We will see this in example 3.6. Example 3.6, find Laplace transform of a unit step function if ft is equal to ut minus 3 minus ut minus 6. So for A, okay, you have ft equal to ut minus 3 minus ut minus 6. Okay, so to find fs, you need to find what is the Laplace transform for ut minus 3 minus Laplace transform for ut minus 6. Okay. If we refer to the table, okay, for this is alpha for this one is 3 and alpha for this one is 6. So fs is equal to 1 over s exponent negative 3s. Okay, 1 over s exponent negative 3s minus, for ut minus 6, 1 over x exponent minus 6s. 1 over s exponent minus 6s. That's it. And then for B, ft equal to t minus 4 square ut minus 4. Okay, so you have this one, the second one, the second shifting property. So Fs is equal to, okay, exponent negative 4s, since your alpha is 4. Okay, and this is, you need to find Laplace for t square. Okay, you have ut and this is t square. This is t minus alpha. T minus alpha square means t square. So for this one, you have exponent negative 4s, and you know t square. For t square, the Laplace for t square is 2 over s cube. For C, ft is equal to exponent t minus 2 ut minus 2. And Fs, since our alpha is equal to 2, so we have exponent minus 2s. Okay, 2, so exponent minus 2s. And then we need to find the Laplace for exponent t. If you have exponent 2t minus 2, so you have exponent 2t. So exponent negative 2s, and the Laplace for exponent t is 1 over s minus 1. Again, if I substitute the equation, I have ft equal to exponent 2t minus 2, for example, ut minus 2. My Fs becomes exponent negative 2s, and then I need to find the Laplace for exponent 2t. Understand? And this is equal to exponent negative 2s 1 over s minus 2. And for B, if I change this, if I have ft equal to 3t minus 4, so this is 3t square. So I have 2 over s cube. Okay. Last, we have for D. Okay. Now for D, ft is equal to t minus y, t minus 5. For this example, you need to modify the t, because to use this table, the second shifting, you need to have t minus alpha, then you have ut minus alpha. But now, what you have here is just t ut minus 5. So to modify this, look carefully. Okay, so you have t, you need to have t minus 5. Okay, you need to have t minus 5, ut minus 5. But this is t, so you need to plus another 5. Okay, so t ut minus 5 is equal to t minus 5 plus 5 ut minus 5. And then you need to expand this, t minus 5 ut minus 5 plus, okay, plus with this. Okay, expand this, plus 5 ut minus 5. Okay, equal to, so t, okay, so to find Fs, alpha is 5. So exponent minus 5, and then you know this is t, plus with, this is constant. Constant, you can use the first row. Okay, table for the first row, so you have 5 over s exponent negative 5s. Laplace for t, exponent negative 5s. Laplace for t is equal to 1 over s square plus 5 over s exponent negative 5s. Okay, so simplify, you have 1 over s square plus 5 over s exponent negative 5s. Okay. Again, I repeat with another example. For example, if you have ft equal to t minus 2 u t minus 3. Our alpha is equal to 3, but now you have t minus another t minus u, not 3. So you need to rearrange. So you need to have t minus 3 over here. But if you write t minus 3, ut minus 3, you will change the ft. We don't want to change the ft. So t minus 3 plus 1 is equal to t minus 2. U t minus 3. Now you have your t minus 3, u t minus 3. Okay, let's say this is A plus B. This is B. Okay, so you need to expand this. A multiplied by u t minus 3 plus B multiplied by u t minus 3. So that's why you have plus 1 multiplied by u t minus 3. Then you can find what is Fs. Fs for this, since our alpha is 3, so negative 3s Laplace t plus this one is exponent negative 3s 1 over s. So the last answer, negative 3s 1 over s square plus exponent negative 3s 1 over s. Or factorize this, you have exponent negative 3s 1 over s square plus 1 over s. In example 3.7, okay, we will look at an example which can be asked in midterm or final exam. Okay, first you need to write, first example you need to write ft in term of unit step function, and then you need to find the Laplace transform. Okay, so ft, first we need to write, so ft equal to exponent negative t, f1 plus f2 minus f1, 2t plus 1 minus exponent negative t, u t minus alpha 2. And this is equal to exponent negative t plus 2t plus 1 u t minus 2 minus exponent negative t u t minus 2. Okay, so you have written this term in unit step function. Okay, to proceed with finding the Laplace transform, you need to rearrange this ft, since our alpha is 2. So this need to be in t minus 2 as well. And this should be t minus 2 as well. So we don't change this first term. It's still exponent negative t, no problem, because this is not in, you don't have unit step here. Plus with, okay, 2t minus 2. Okay, because we need to have this t minus 2. And if you have this 2t minus 2, this is equal to 2t minus 4. But your original ft is 2t plus 1. So what you need to do is to plus with 3. So 2t minus 4 plus 3 becomes 2t plus 1. Okay. Then u t minus 2 minus with exponent. Okay, instead of negative t, we need to have negative t minus 2. Okay, and then we need to plus with 1, sorry, with 2. So t minus 2 plus 2 is t. So we don't change the value of this ft. Okay, so u t minus 2. Okay, and this is equal to exponent negative t plus 2 t minus 2 u t minus 2. Okay, and then I expand this plus 3 u t minus 2. Okay. For this exponential means exponent negative t minus 2 multiplied by exponent 2. Okay. Okay. Exponent 2. So we have exponent, sorry, this is exponent negative 2 because we have negative over here. Exponent negative 2. So we have minus exponent negative 2 exponent negative t minus 2 u t minus 2. Okay, only then we can proceed with finding the Laplace transform because everything is in t minus alpha. T minus alpha. So to find Fs, Laplace transform, the normal Laplace transform for exponent negative t is equal to 1 over s plus 1. Okay, then we start with the unit step function here. So 2t minus 2 ut minus 2. So exponent using second shifting, exponent negative 2s. Then you need to find the Laplace for 2t. Plus 3 ut minus 2. So 3 exponent negative 2s. Minus with exponent negative 2 is our constant. Okay. And then you have exponent negative t minus 2 ut minus 2 multiplied by this unit step exponent negative 2s. And then Laplace for exponent negative t. Okay. So 1 over s plus 1 plus 2t. Laplace transform for 2t is equal to 2 over s square multiplied by exponent negative 2s plus 3 exponent negative 2s minus exponent negative 2 exponent negative 2s Laplace for 1 over Laplace for exponent negative t is s plus 1. Okay, so simplify this s plus 1 plus, okay, 2 over s square plus 3. Sorry, this is we have over s constant. 3 over s exponent negative 2s. Minus with, okay, exponent, products of exponent. So we have plus. So plus, we have negative 2s plus 1 divided by s plus 1. Okay. Okay, one note here. Okay, before this, when you use first shifting properties, you have your gs, right? And then you need to find what is gs minus a. But in second shifting properties, you have ut minus a. And from ut minus a, you need to change it to ut. For this example, exponent negative t minus u, t minus a. So you change it to exponent negative t. From here, from this to this. Okay. This last example is from the past year questions. So given ft, 3t minus 5, 3t and t square. And then we have the interval of t. Then first we need to express the function in terms of unit step function. So first ft is equal to f1. f1 is 3t minus 5 plus f2 minus f1. 3t minus 3t plus 5. u t minus 2 plus f3 t square minus 3t u t minus 4. Okay, and then for this we have 3t minus 5 plus 3t minus 3t is 0. So we just left with 5u t minus 2 plus t square minus 3t u t minus 4. Okay, then we need to find the Laplace transform of ft. But since this t is not in term of t minus 4, not in unit step, okay, so we need to change this, modify this t square minus 3t. Okay, so for this we have 3t minus 5 plus for u t minus 2 plus we need to have t minus 4 square, okay, minus 3t minus 4 as well, u t minus 4. But this is not equal to the original function, the original term. Okay, t square minus 3t is not equal to t minus 4 square minus 3t minus 4. So we need to make sure this t minus 4 square minus 3t minus 4 is equal to this. So we need to do some modification on this. So we have 3t minus 5 plus 5u t minus 2 plus for t minus 4 square. T minus 4 square, okay, t minus 4 square, this is equal to t square plus, t square minus 8t plus 16t. Okay, so this term we need to substitute this term, to find the substitution for this term. So for t minus 4 square, we need to add another 8t minus 4. Okay, plus 8t minus 16. Okay, this is not 16t, this is 16. Okay, so we're done with this t minus 4 square. And then for this negative 3t minus 4, it is negative 3t plus 12. So we have extra 12 here. Okay, we need to remove this 12 by, okay, so we have next 3t minus 4. So you need to remove negative 12 from here. U t minus 4. Okay, so 3t minus 5 plus 5u t minus 2 plus t minus 4 square plus 8 minus 3 is 5. 5t minus 4. 16 minus 12 is 4. U t minus 4. Okay. So 3t minus 5 plus 5u t minus 2 plus, we need to expand this in unit step function. So we have t minus 4 square u t minus 4 plus 5t minus 4 u t minus 4 plus 4u t minus 4. Now we can find what is the Fs one by one. Okay, Fs for 3t is equal to 3 over s square. Fs for negative 5 is negative 5 over s. Fs for 5ut minus 2. So 5 over s exponent alpha s. Plus, for this one, we know it is exponent negative 4s. And then find what is Laplace transform for t square. Plus 5 exponent negative 4s Laplace transform of t plus 4 ut minus 4, we have 4 over s exponent negative 4s. Okay, now 3 over s square minus 5 over s plus 5 over s exponent negative 2s plus exponent negative 4s t square. T square is equal to 2 over s cube plus 5 exponent negative 4s. Laplace for t is 1 over s square plus 4 over s exponent negative 4s. Okay. Or in a better way, or we can write as 3 over s cube minus 5 over s, 5 over s exponent negative 2s, negative 4s, 2 over s cube plus 5 over s square plus 4 over s. This is the last answer. 13 marks in final exam. Okay. That's all for this week video. In next week video, we will see the inverse Laplace transform. Okay. Thank you.